Yo, this is Mr. Boyle, and this is Check Your Understanding 2.1. This is part D. This one deals with transforming or moving data on here. So they go back to Mrs. Navard's class. It was dealing with height. So they have this dot plot down here, which was the one that we just dealt with previously when we were working with z-scores. So what this says here is suppose that you convert the class's height from inches to centimeters. So in 1 inch is 2.54 centimeters. And it says describe the effect this will have on the shape, center, and spread of the distribution. So big thing here, multiplying. When you multiply, it affects everything except for the shape. So shape is never changed. Doesn't matter what you do, it's still going to look the same. So this dot plot that you see down here is still going to have the same peaks and the same look to it. The only difference is that the mean and the median, of course, are going to be much larger because the numbers will have been multiplied by 2.54. The spread also is that the smaller number, when you multiply it, is going to be multiplied by 2.54, but these larger numbers also will be multiplied by 2.54, which causes the spread to increase as well. All right. Number two, so Ms. Navar had the entire class stand on a 6-inch platform and then had the students measure the distance from the top of their heads to the ground. How would the shape, center, and spread of this distribution compare with the original? So remember, this dot plot is them just standing on the ground normal. She has now had them stand up on a 6-inch platform, which is adding 6 inches to their original height. And so all that's going to do, is the shape and spread will not change. So all you're doing, and this is one of those little tricky things, when it comes to adding, the shape, number one, never changes. So that's not going to change no matter what you do to the data. If you multiply all of them, you add all of them, subtract, or divide. But in this situation, if you add or subtract, the shape and the spread will not change, because if I add 6 inches, every single one of these is going to move over 6. So all we're doing is really just taking the entire graph and just sliding it to the right 6. So that's not going to have anything to do with it. The one thing that it will affect is your mean and median, or your center, because now all these numbers are going to be 6 inches higher, every single one of them. So that when I go in and find the center is not going to be in this area here, which they say is 67. It's not going to be this point. This point's literally going to be over 6 more spots. Every single one of them is going to be over 6 more. So therefore, causing that to change. So the last thing we'll talk about here is now that you now suppose that you convert the class's heights to the z-scores. So now we go back and we say, hey, instead of looking at them at raw scores, how do they compare in terms of standard deviations and how far they are from the mean? When you do this, the shape, again, is not going to change. It's still going to look exactly the same, except now your center point, your mean is 0. That's like spot on. So this 67 is going to be 0 because it's spot on the actual average that it is for this class. Then every other person from there will jump out by a standard deviation of 1. So based on every 4.29 that we go out, that'll count as 1 standard deviation as it jumps. So the big thing here is when you go to z-scores, you start breaking it down, but median is the mean is going to be 0, and then everything from there out is going to be a standard deviation of 1. Hey, this is Mr. Boyle, and I'm out.